Let's play some music with Java and Kotlin.
Welcome to the Foojay Podcast, all your news about OpenJDK.
MIDI is a universal standard to communicate between music instruments and computers. Within OpenJDK, there is a whole JavaFX package dedicated to MIDI communication and data handling. But is it up to date? Are there better approaches now? And what can we do with music, Java, and Kotlin? Let's find out with my two guests.
My name is Geert Bevin. I've been a Java programmer for as long as I can remember. It started actually, I think, with JDK 1.0. And then I've been sort of moving in and out of the Java community as it felt appropriate, but also been a musician for most of my life and actually started using synthesizers and MIDI a little bit before I started using Java. So I bought a few of the first synthesizers that were digital and that were able to connect with the MIDI cables to each other, and then to the first MIDI interfaces and the first tools that are called now DAW to be able to record and sequence that MIDI data that would be sent between the synthesizers. And then my passion for music and computers and programming has sort of led me to very interesting places, including where I am now. I've been in this role for 10 years. I work at Moog Music, which is one of the first synthesizer companies that existed. And we are still alive and kicking and doing really cool stuff. And I'm leading the software development team there, which comprises both iOS, macOS, Windows apps, and audio and MIDI plugins, as well as firmware on the hardware devices and editors that allow the hardware devices to be better integrated with the actual digital ecosystem. So that's a very quick overview of how this relates to me, I think.
Hi, I'm Atsushi from Japan. I used to be rather a .NET developer for many years until 2018-ish, and then I kind of turned myself into an Android developer people in the community. And my primary language is C++ and Kotlin for some audio and MIDI applications for a while, without any jobs for a while. And then when I was a .NET developer, I created the first cross-platform MIDI library in .NET. And then after I graduated in C#, I kind of wanted to do the same in Kotlin, and I'm mostly for Android. I mean, I've been using my C# library in Android, and then wanted to do the same in Kotlin nowadays. And now Kotlin has become multi-platform ready, so it's getting quite similar to what I had in C#.
And I'm Frank Del Porte, Java programmer, technical writer at Azul, and producer of this podcast. And as a producer, I'm totally free to pick my topics. And because I'm working on a pet project where I try to visualize music, challenged by my son, my 14-year-old son, I dove into this whole thing of MIDI and what is it and what can you do with it and what can you do with Java. And that's how, I discovered both of you. Geert, I follow you already for quite some time as being a Belgian Java champion, the first one. And I discovered your library, Atsushi, that you created with Kotlin and MIDI. So thanks both for your great work and what you will share online. Before we dive into what we can do with MIDI and Java and Kotlin, what is MIDI exactly? So it's a protocol between devices, music instruments, correct?
It is. MIDI got invented in the 80s when the first synthesizer sort of came about, and there was a definite need in order to be able to connect them together. And it's pretty remarkable, actually. that usually when standards like that appear, they don't appear as standards, but you often have corporations that create their own thing, and then everyone sort of does their own thing in their corner. But what is pretty remarkable about MIDI is that like companies came together and like Roland, Yamaha, Korg, Moog also back in the day was looking at it and created this standard that's very, very simple as a means to basically encode what musical data is, both real-time and non-real-time. And the MIDI 1.0 spec has essentially not changed much since the 80s. There's been additional extensions written for it. There's been different ways of using it, for instance, for light control or for more expressive control. And that is probably why you have not seen many changes in the JavaX package, because there hasn't been that many widely adopted changes. Now, pretty recently, there is the MIDI 2.0 standard. It's been worked on for a long time, but pretty recently it's ramped up very quickly, and there's a lot of companies interested in it, including operating system companies. And so if it's probably time for the JavaX package to be updated and to use the MIDI 2.0 functionalities. But MIDI 1.0 is still the widely available, the one that every musician uses, the one that every DAW basically has access to.
And to dive into the data itself, so I've been experimenting a bit. I also have my piano next to me, piano of my son, to do this. Actually, when you hit a note, you receive 3 bytes.
2 bytes, yeah.
3 bytes.
Yeah, a MIDI message is either 2 bytes or 3 bytes, depending on what type of message it is. That is enough for most of the instruments until now, but that is where MIDI 2.0 comes in, because we now have instruments and devices that have like sensors that are way more capable, that allow you to be way more real-time expressive in the digital domain. And for these type of performances, MIDI 1.0 is a little bit limited, but for the majority, it's still perfectly fine.
You mentioned the JavaX package. So indeed, if you go into the OpenJDK sources, you can dive into these sources. They are on GitHub. What was it? I was looking into it. So they didn't change in the last 6-7 years. And I think most of the changes were because the repository moved from a hidden one to GitHub. So I don't think there were a lot of changes. So it's really that stable. That's the idea behind it. It's just a standard, stable specification.
It's extremely stable. Like there's just not many changes necessary. It's pretty remarkable, actually.
At the same time, the platform API didn't improve the MIDI support a lot. Like Windows still uses the WinMM from Windows 90 something, and then we have actually more features that we wanted, like say creating arbitrary virtual MIDI ports so that we can dynamically create some virtual synthesizers or virtual inputs dynamically, but it was not really doable until every OS and platform supports those new features. And actually, while MIDI 2.0 is almost ready, we still have to wait for every platforms to support it.
So this MIDI 2 also means that devices, music instruments also will need to change, or newer instruments will have this new MIDI 2 specification built in.
The way MIDI 2.0 is structured is that it incorporates MIDI 1.0, and whenever a connection is made, there is a negotiation that happens that indicates which level of the transport protocol is being used. The one big difference between MIDI 1.0 and MIDI 2.0 is that MIDI 2.0 requires bidirectional communication. So you have to be able to receive and send from any device that is connected with MIDI 2.0. With MIDI 1.0, that wasn't necessary. You could basically just daisy chain a whole bunch of MIDI 1.0 devices and never have information come back.
Did I see correctly here that you were even at a conference recently where the MIDI specification was defined or discussed?
I'm part of MIDI Association. I used to be, for 2 years, I was on the technical standards board of the MIDI Association. And I've been participating in quite a few working groups. I actually represent Moog Music at the MIDI Association, and also some other interests. And there's this one specification that I personally have been very interested and passionate about, and I actually started that effort, which is called MPE, MIDI Polyphonic Expression, where you basically use MIDI 1.0, the old specification, the 40-year-old specification, and use it with more modern expressive devices. So sort of creating a bridge to allow people to experience what is currently possible with real-time electronic music playing without necessarily having to go all the way to MIDI 2.0. So yes, and then we had in Berlin, we had a meeting 3 weeks ago, I think, right before the trade show. It's called Superbooth, where we met with representatives of Apple, Microsoft, Native Instruments, Avid, Ableton, Bitwig, Moog, of course, Yamaha, to sort of make more concrete plans on how to accelerate the adoption of MIDI 2.0.
So you work on these instruments. I guess those are more C development that you're doing there. Is the Java involved in the things you are doing?
There is no Java involved on the actual devices. The problem is still garbage collection. It's still like the risk of having non-real-time like threads happening. And you could go into real-time Java, but it's like pretty big ordeal to get that to work right. Sometimes people think about like latency that the garbage collector would introduce. Latency is not that much of a problem in practice, because humans really deal well with latency. You can deal with up to 12 milliseconds of latency without even noticing it. It's basically the latency of the sound traveling across the room. If you would have your amplifier on the other side of the room and you play, it's about the same type of latency. So we can deal with that. The biggest problem is jitter. And jitter basically means that whenever action happens, let's say someone plays a note, and then whenever the code processes it, that latency is not constant. Like it shifts around. And that tolerance is very low in human beings. It's sort of academic studies have found it lays between, depending on everyone's sensitivity, between 1 and 5 milliseconds, which is it's very low tolerance. So in that sense, like Java is a little bit problematic for real-time like MIDI performances.
You mentioned also a bit that MIDI cannot contain enough data to handle new instruments. Is that the big evolution we see in music now? You have these instruments where it's not just a note being played, but you have this touch-based like interfaces, and you can bend the note a bit and press it harder. Are those the challenges that MIDI 1 cannot handle?
MIDI 1 can handle it up to a certain level. So that is that specification called MPE that I worked on with the working group, which is based on top of MIDI 1.0. One of the approaches there it takes is, like, just a very quick summary for people who have never used MIDI 1.0. MIDI 1.0 is basically broken down in channels. You have 16 channels on a port. And the original intent was that each channel or ranges of channels are being used by different instruments or different devices, right? And then when these new instruments came about that were able to express in multiple dimensions for each touch, that specification called MPE basically reframes what a channel is. Instead of saying a channel is a device, it's basically a channel is a finger. So now your finger can be as expressive as older devices used to be. You have like 10 fingers, so 16 channels are more than enough. But it's still like limited a little bit in the resolution. Most of the messages are still 7-bit. Some of them are 14-bit. Now we released a new MPE specification, I think it was two or 3 months ago, which sort of goes halfway, where we introduce new parameters that can use 14-bit data across all three axes. But MIDI 2.0 goes way farther. It's basically 32-bit for each value.
Yeah, but yeah, we evolved a lot. We can handle more data. We have better communication channels. So I think, it was time for an evolution. Atsushi, so you have this library that you created, which is a Kotlin library to interact with MIDI. What was the reason that you created it? So you said you wanted to port your C# work to Kotlin. Why did you use Kotlin? Why not Java?
It totally depended on my technical background. Like, it was originally written in .NET, and I was also an Android developer. I mean, I had been working at a company called Xamarin. Well, because before that it was Novell, and I was working in a project called Mono, which implemented open source version of a .NET alternative instead of Microsoft. And while Microsoft had been doing those stuff only on Windows, we had been cross-platform in the first place, and we had been we started from Linux and then extended the support to Mac OS and even Windows, and then extended it to embedded software as well. And then when mobile OSs showed up, like iPhone and Android, it was natural for us to extend our support to those platforms. And then when I joined Xamarin which was a new company after Novell, I was a part of the Xamarin Android team, and then wanted to bring in my cross-platform .NET library to Android as well. I also supported iOS later, but the Android was the first place, and then Android was totally a Java world. But while I was working in that company, I was mostly tied to Java and couldn't really use Kotlin as a development language because, when you're working on that kind of a project, I mean, non-native languages such as React Native or Flutter, those things, you're supposed to stick to Java and JNI things to interoperate with those native platforms. And I was also part of that stuff as well. And then after I quit Microsoft, I could totally I could totally switch to that Kotlin language, and Kotlin was way closer to C# for me, and it was a natural choice for me to switch to Kotlin. And since I was Android first, and the Kotlin was the first choice by nature, and then they started supporting Kotlin multi-platform later, and then porting my library to Kotlin was almost natural fit for that kind of purpose too. I didn't really start porting my cross-platform MIDI library itself in the beginning. I had another project that supported a virtual MIDI synthesizer called Fluid Synth. That was a virtual MIDI synthesizer on Linux desktop, and it was actually designed to be cross-platform. So I wanted to bring it to Android as well. And actually, I'm a contributor to Fluid Synth project itself to bring in the Android support as well. And I had a .NET bindings then, and then later I had the abstraction layer for any MIDI device accesses in my code. So I had usually when you create some abstraction layer and your actual implementation for those abstraction layer would be platform API like VMM, MIDI access, core MIDI access, ALSA MIDI access, or that kind of stuff. Then Kotlin became cross-platform. I could bring in my library to Kotlin world from the abstraction layer. And then I could use that library on Java desktop as well.
And I can confirm, I'm using your library in my pet project, and I can seamlessly connect to any piano that I connect with or another MIDI device. How do you compare your library to the JavaX MIDI package, or didn't you really are you using JavaX MIDI, or is it completely your own implementation?
It would be a hybrid answer of yes and no. I do use JavaX XML, no, sorry, javax.sound MIDI to implement MIDI access to, access to MIDI devices on Windows, but not on Mac OS and Linux, because on those OSs, I use a cross-platform MIDI API library called AltiMIDI, and use JNI to access to those libraries on Kotlin JVM. Kotlin multi-platform actually supports various different backends like Kotlin JS and Kotlin native, and they need different access to those native platforms for each language. Like in Kotlin native, they have a foundation called C-interrupt, and they need some native support. I mean, there's specific support for native backend, and Kotlin JS as well. And it would need maybe Node FFI kind of stuff. And I do use some library called JZZ, which offers access to those libraries. And on JVM desktop, the reason I didn't use JavaX Sound MIDI was that they don't really offer the way to create virtual ports that I mentioned earlier. And on Alsa and Core MIDI, we can with that. And OpenMIDI, the cross-platform library, also supports that.
I will add to the show notes the link to your repository because it's open source. Everyone can visit it. How is it used at this moment, ktmidi? Is it already in a lot of applications? You have your own demo applications where you use it in? Are there many more already?
Not many more. It was created mostly for my own purposes. I wanted to bring in my virtual MIDI keyboard applications, especially because it was crucial to my creative process. Like I launch DAW and use my virtual MIDI keyboard to play it. And I'm not a piano player. I do have some physical MIDI keyboard, but I don't really use that very much. Then I wanted to bring my application in the first place. I also had some virtual MIDI player, and I did use that to say, I would say debug whatever I created in the standard MIDI file. It visualizes everything in the manner that I used to play those MIDI song files back in 20th century, like when I was using FM synthesizer, and they had their own visualizers to make it possible. So I wanted to bring it the same. But it still haven't happened in Kotlin yet because I had to deal with the graphics layer in Kotlin multi-platform, and it was not really ready at that moment.
Well, I can tell you that your application or your library works perfectly with Java and JavaFX, which is then another one of my hobby projects, building user interfaces with JavaFX. And
I saw that, yeah.
Yeah, and because of your library being in Kotlin, I started using JavaFX and Kotlin, which I have to admit that I do love Kotlin. There are some ways how you can define objects and fill in the parameters, which is different than how you do it in Java.
C# is closer to Kotlin rather than Java because, say, I don't really want to deal with something like throws, expressions on the method declarations, and it was similar in Kotlin than C# to C#. And then using Kotlin multi-platform, and maybe even Kotlin JVM is not really blocking for Java users. Like when I publish my Kotlin library, it would be a simple JVM library, just a jar for Java developers. So like you could simply use my Kotlin library. The Kotlin would be just regarded as an implementation language. And as long as I pay some attention to not generate awkward Java API, it would mostly work.
I don't know for you here, have you taken the path from Java to Kotlin, or do you stick to Java? Because you're mostly working in C and C++. So what direction do you take now?
I've stuck to Java. I feel that, back in the day, it was like there were so many years between major Java releases and between like language updates. And then it was like, sort of feels like the dark ages, like there's the dark ages where nothing changed, right? But then with the yearly releases now, like there's so much innovation and great progress in adopting tasteful new language features and doing it in such a way that code still continues working. And when I started programming, I was very much about like a polyglot, trying every language under the sun, which creates problems for maintainability. Like I've been bitten by that so much in the past. And it is one of the things that I really appreciate about Java is I can open a 20-year-old project up and it works. I can compile it. I can gradually like adopt new features, work through it. So even before like the days of Java 1.4 and stuff like that, I felt it was worth paying the extra overhead, even in boilerplate code. But even then, like with all the changes now, I think it's become extremely comfortable. It's definitely not comfortable at a Kotlin level, and I've felt that I don't use Kotlin. I use Swift a lot on the Apple platforms, which has quite a few like overlaps and like syntactical overlaps with Kotlin. I do miss some of these language features, but I also have been bitten by all the Swift versions, like where all of a sudden Swift 4 comes out, and like we're now at Swift 6, but Swift 4 came out, and sort of the world stopped. Like you're like, okay, well I got to start over basically. So yeah, I've not really jumped on Kotlin.
You mentioned Swift. I've seen some of your work that you shared recently. So you've been working with this new, what is the glasses thing called for Apple?
The Vision Pro.
The Vision Pro. You created apps for that. You created apps for your watch, where you have interaction with MIDI devices. Is this all part of your job? Or are these
some of it is. So we, as Moog Music, we basically created the first spatial synthesizer on Vision Pro. It's called Animal Galaxy, where you basically can play, like there's a very old electronic instrument called the theremin, where you hold your hand next to an antenna, and then there's a field where you can change the pitch and you can change the volume with your other hand. So that is one of the instruments that started the founder of the company, Bob Moog, on its journey. So what we did was looking at the Vision Pro's gestures, and the Vision Pro gestures are basically you select with your eyes. So your eyes are basically moving your mouse. It's like you move your mouse around, and then you use your fingers as a pinch and drag to interact with whatever you're looking at. Which actually makes perfect sense for musical expression. So, and we already had a synthesizer that we made for iPad. We have quite a few, but we made the first like professional synthesizer on iPad about 12, 13 years ago, called Animoog. And we sort of revisited that and reimagined it for what it would be in a spatial computing context, which was a lot of fun. It was a really great project. Still working on that. Actually, I just went to WWDC. I just came back late last night. Got some cool ideas to further improve it. And then there's a bunch of projects that I do by myself. I have my own company with which I do all the projects that I know will not make any money. And because I'm very interested in the human-computer relationship. Like How far can a computer or new sensors allow humans to reach different levels or higher levels of expressiveness to make audio and music actually way more emotional, way more personal, which is typically not what people would be thinking about when you say, hey, there's a computer in the mix, like it'll become like stale and digital. And like, I actually think there is a really cool avenue where that is the opposite. And so that is where I've been creating like a lot of different products, including like one of the latest one I did was a re-implementation of an app I did 6 years ago called MIDI re-implemented called MIDI Unleashed, where it's like a fully standalone MIDI controller on your watch that can talk over Bluetooth to any MIDI device that supports Bluetooth. And then you can use motion control with your hands and use accelerometer control to sort of trigger things with different velocity. And it's just fun. It's a fun projects. And then I usually package these up, create a proper product out of it with tutorials and manuals, put it on the App Store and see what happens. And then often people use it for a lot of really cool things that I've never imagined, which is very gratifying.
So you're actually inventing new ways to make music.
Yeah.
Through your watch, for instance.
Yeah.
Atsushi, you mentioned you're not really a piano player. Are you a music player?
I don't really use instruments. I mean, well, when I created that MIDI player, I was mostly using the fluid synths. And then I have changed myself a lot more like an audio developer. And my primary field is audio plugins instead of MIDI devices. And I still support MIDI extensively, especially MIDI 2.0 in my I built in my audio plugin stuff. Like I'm not building audio plugins by myself, but I'm rather building audio plugin format like VST or audio unit or club. And iOS has audio unit v3, and I built my own version of audio unit for Android. And I have been using the MIDI 2.0 as an event format. And so that's one of the reasons I wanted to extensively support MIDI stuff in my own library in both C++ and Kotlin. And then those MIDI player kind of features have kind of moved into my own Android and audio projects.
So you're both creating these open source libraries, sharing your work. Geert, I heard in the podcast of Adam Bean, you moved a bit away from Java, and then you totally came back and created Rife2 and BLD, and you're now competing with Maven and Gradle. Is that correct?
I'm not trying to compete. It's just...
It happened.
I think it's an interesting... I don't know if anyone thinks it's interesting, but I think it's interesting. So I'm going to tell the story. So 2 years ago, working on new products with my team at Moog Music, we had done a lot of iOS and macOS sort of Apple App Store limited software. We were going to create a whole new range of plugins, and we wanted to incorporate Windows support. And with that, we wanted to allow customers to have a direct checkout and distribution process through an online site, like typical stuff. And so we started looking at what was available out there. And I was very disappointed in the solutions that I could find where you would have a flow where a customer would come in and you would have like a digital distribution of any type of package, but then be able to have automatic updates, versioning, also allow the same fulfillment flow to be used with retail stores. Like people would walk into a music store and say, hey, I want to buy this piece of software. Couldn't really find a solution where you would have a code to redeem that would then go through the exact same fulfillment process, and everyone would sort of be funneled into like the same user account, the same like maintenance process afterwards. And we tried a few things out. Like we tried Shopify with a bunch of plugins, and we tried another platform called Sendow, which was supposed to be like really good at that, but then we hit some major roadblocks in that. But the other thing that we really value is we want to be able to fully be in charge of the entire process. We want to be able to theme it all to make it really look like Moog, feel like Moog. Every single email should look and feel like Moog. Every single step in the interaction should be completely like curated, so that our customer experience feels like right at home with our like overall customer experience. And couldn't really find anything that worked right. So I was like, this is not hard. Like the problem there by itself is fundamentally not a difficult problem. The biggest problem is the financial transaction. And luckily, we have Stripe and PayPal, which have like extremely well thought out APIs and fulfillment flows with various level of integration that you can have. You can like be completely hands off and have just a JavaScript API, or you can dig all the way in and have like a REST API to tightly integrate these solutions without having to deal with these complexities of financial transactions and global transactions. And so let's do a little spike and try to come up with a little application using whatever framework that was out there to build this flow out for our checkout. And so I was like, I'll just pick Java because I know Java. I'm like, let's just go in and do this. And Stripe had all these examples written with the Spark framework, which is a very lightweight Java framework. I liked it a lot. And so I had a little example going, and it was like all not themed. It was like very bare bones HTML. And then I had to go to the next step. And now I had to find a template engine. And that is sort of where like the shit hit the fan. Because I had been working on a framework myself 20 years ago called Rife, with the first version of it, where I basically, the intent of that framework at the time was, I was coming from a PHP experience. I was like, why is Java not as easy as PHP to really quickly just get something out there, right? Back in the day, it was Enterprise Java Beans, and it was very, very heavyweight. It was even more heavyweight than Spring was. Spring was a breath of fresh air at the time, right? And so I had that framework that was sort of my realm back in the day. And I came up with a template engine back then. My brain still worked that way. Like, this is the way templates should work, which is completely different than any other template engine in the planet. Coming from an architecture and a design background, I always felt like templates just had to be like dead pieces of content, just stuff like scrapbooking that you can very freely cut up in pieces, and then you have some other process that like assembles them. Like, to me, templates never had to be in charge of the flow. There should never be any flow control at all, ever, in a template. And that historically in the web world, this has sort of been the opposite. And I wasn't looking for a template engine, and they just all felt wrong to me. So it's like, you know what? Maybe I'll go back to my old template engine, and I port it to like Java, I think it was 17 back then, and see how it goes. And it was like a little weekend project, and it got it working, and it's like really cool. Hey, we got the templates running in Spark. And then it's like, but now I need to actually get more complicated path info handling, and I need to have a little bit more control over my routing. And why do I have to hard code URLs in my templates? Like, it's like, well, why is there no solution for this? And these were all things that I had solved in my old framework. And so as time went on, and this was like really rapid, it's just a matter of weeks, like while we were prototyping this thing, it was like, oh, you know what? Let me pull in that other piece from Rife1. Let me pull in like the authentication layer. Let me pull in the database support. Like, and before I knew it, I had basically pulled in 80% of my old framework, except for the whole routing architecture. It's like, let's just do the whole thing, right? And then I looked at the capabilities of Java 17 and how I would reimagine what a site definition and a routing definition would look like without any declaration, just pure Java, allowing you to use lambdas, allowing you to use like class suppliers and all of that stuff. And I ended up with Rife2 that we use to build out the whole e-commerce platform at Moog that is like very, very powerful now with promotions and affiliates and back-end reporting and like everything we wanted. And that then led into like me getting my team who had never done any Java, who was like, they do C, C++, Swift, maybe Go, like getting my team on the Java platform. And the first thing that they struggled with, obviously, Gradle. Like, oh my God, what is this thing? Like, it's doing all these weird operations that I really don't have control over, and any build process sort of like gets slowed down by dependency resolution, and then there's a new version that comes out, and all of a sudden the syntax doesn't work anymore, and so I was like, this feels way too complicated. While again, like the same premise. Well, the problem is simple. The problem basically is I just need to compile a bunch of files, and I need to say what my class path is like, and you can do it on the Java command line. It's not that hard, right? And it's like, maybe I should just try to write this in Java, see what happens. And I was sort of joking around online with Eric Touvin, who wrote like the Link blog, and then Cameron Purdy, who was at TangoSol and Oracle. It's like, oh, maybe I should just like create a Java build tool. And I'm like sitting like in the couch at night, like, maybe I should create a pure Java build tool. And then again, just like did a spike for a week and came up with something that was actually really small and comfortable and worked and did everything I needed. And my team like completely adopted it, like felt it was very comfortable. And then a few more people saw what I was doing, and eventually turned out into this. Initially was integrated into Rife2 as like, oh, just an easy tool to get Rife2 projects going. And then there was more and more interest to have this very lightweight, fast, intuitive, imperative build infrastructure. And I extracted it and worked a lot on it with Eric Touvin, who helped a lot, like figuring out all the fine details of different types of projects. Like he has a massive catalog of open source projects, like 70 or 80 open source projects. And so he started moving all of these over from Gradle to build, and then giving feedback. And that's where we are now. Like it's been pretty interesting because I had absolutely no desire to create a build tool.
It just happens.
And I had absolutely no desire to compete with Gradle or Maven. Like, this is just not my, like, I don't want to do anything commercial with this. I actually like just hope that it's useful for people, because I think in an open source sense, so I just publish it online and see what the feedback is. And it's been great. I'm using it, my team's using it, a lot of other people using it. It's got quite a few stars on GitHub. Like there's been integrations with various different tools and stuff like that. So yeah, it just happened.
I find these stories really inspiring of how things just happen. So you thought we need a better way to make our website. Atsushi, you wanted to port your code to Android actually, and then it happened to be Kotlin. We had the closing talk at Devox was the creator of the Rockstar programming language, which also just happened and fits in this topic of music. So yeah, things just happening because you want to solve a problem for yourself, and then actually find out if you distribute it that you can help a lot of people. Here you make your money of making music applications and working for Moog. Atsushi, is this also your job now? Or is interacting with music instruments now part of your job?
Not really. I'm jobless. I build my own stuff just for fun, and I think a lot of the things I have been doing is quite unique, and no one else is actually doing that. Like, say, no one builds audio plugin formats for Android, and no one builds the MIDI 2 implementation up to the almost highest level, except for maybe Juice library, which is written in C++. And the Kotlin, I'm definitely the only one, and it's kind of fun to explore that kind of the most advanced stuff by myself.
And then I'm combining your library, Atsushi, with JavaFX, which is also not a typical use case to make music applications. But yeah, indeed, it's fun. It's discovering new technologies and just trying out and see what you can learn out of it. So I'm happy here that you also rediscovered Java and how it evolved.
There's another side to publishing. I've been doing open source for, I think, my whole career. In some form or fashion. And I really like that public development process. And sometimes I can't do it because it's a commercial product and it's just not possible. But I always try to have a few things that happen in public where whoever is interested in that niche you're operating in can immediately give you feedback. And you never get as many ideas or create as cool things as when there's multiple people sort of very spontaneously see how it impacts them and like what their thoughts about it are, and maybe even contributes. And that's also why I usually always write public documentation and sort of try to make it as easy as possible for people to just give it a go. See, like, oh, maybe I like this, maybe not. And if you don't, that's also totally fine.
It's almost similar. Like the open source is the default for me as well. And then, well, not a lot of people actually reach my project, unlike people like you. But there are certain people who want to explore and find some niche software like I developed, and then they give some very nice feedback, and that's always fun to deal with.
Mm-hmm.
And if I want to work on quite big projects like Mono I used to work on, I could always join such company and then start working at any time.
I also understand both your story about open source. I have one challenge with my music app that I'm developing. So the idea is from my 14-year-old son, and his idea is that he will become extremely rich because of it. So
yes, of course.
Yeah, so I cannot make it open source, but as an open source developer, I will do part of it open source.
Yes.
There's a big difference between dreams of teenagers and the actual world.
But not even teenagers. Like it's really interesting. I think that type of thinking. I like if you interact with people that are not in our industry, and I've had it. I suppose you guys have had it too. Like with your partner or your parents, or where you're like, I'm just doing this thing for free, but I need to work on it the whole weekend because like it needs to be good. And they're like, what are you doing? And you're giving this thing away. Why are you spending all this time on it? Well, I mean, it has to be good. Like everyone's gonna see it. And I want it to be as good as it can possibly be. And it's this cognitive dissonance. It's like, but where's the money? And then if you just should keep your ID to yourself, and then you're gonna make a lot of money. I've never seen that work. No. Never, ever.
I just recorded a video that I will put online in the series JavaFX in Action. And that's Christopher Schnick. And he's a one-person company building a JavaFX tool to interact SSH and VNC with devices, your Docker environment, whatever. And it's the same story. He's creating it in the open and selling it with some extra features. Wherein, again, the idea is, we make tools because we use open source libraries. So we should also share what we are creating and how we are creating, how we are using it. The tool I'm making since yesterday, Steve Hanna helped me to set up the JDeploy build process so that it just builds on GitHub, and if you installed it once, you will always get the latest versions. These tools, which are just available, which just work and are maintained by the creator and other people using them. But yeah, that's why I love the whole Java environment. And I don't know, maybe Atsushi, you can compare it with the Windows.NET C# environment.
I would say Java had been always open, and they are more like community-based development what happened. Like, say, in .NET world, lots of people were expecting Microsoft to work on this and that, and they always wanted some genuine kind of stuff, and it was a remarkable difference. But .NET is also getting open source, and it became open source, and then there are more people like ourselves. I mean, Mono was always like more like a Java, and everyone in the community contributed the code as well. And so I think .NET became quite similar. And the entire .NET team was quite open on GitHub and to accept issues and pull requests and whatsoever. So I think they were getting better.
Mm-hmm. Yeah, it's not only the tools. I also like the community and reaching out to people like both of you and just being able to have a chat and discuss all these kind of things. Okay, good. Is there something more you want to share?
If you want to check out like the Java stuff I did, it's Rife2, RIFE2.com. And then that also leads to build, and then leads into dozens and dozens and dozens of pages of examples and tutorials and documentation and whatnot.
I will add all these links to the show notes of this podcast, so they will be both in your podcast app, in YouTube, and in a Foojay blog, of course. And the same, of course, the library of you, Atsushi, so that people can find it there and start experimenting with music and Java and MIDI and Kotlin and whatever they want to include in the mix. Okay.
All the things.
Thanks a lot for your time, and hope to see you soon.
Yeah, take
Thank
care.
you both.
Bye.
Yeah.
Give me a foo, give me a J, give me the friends of OpenJDK.